Welcome everyone. My name is Andrea Costa. I am the co-founder with Tom of IoT-enabled Solution. I'm very happy to be at Sustainable Places and touch once more all the issues that we have been discussing in these days. So the workshop today it's on enable digital twins and building management system on how to innovate ICT services and my contribute to the spread of smart building technologies. So we will have an overview on 4 European projects, which will be presented shortly. My contribution to this is just, let's say, an initial introduction and moderating the session. So there will be this kind of introduction I'm just going to give now. Then we will have 2 projects, that is iBECOME and AutoDone, presented by Dimitros and Beatrice from IES. Then I will take the floor again quickly for a small kind of survey that we will take online with your mobile phone and Slido, if you know it. A couple of questions. Then we will have 2 more projects, one from Amisha and the other one from Niall, again, both from IES, and we will have some space at the end for discussions. So, 2 things about why I'm doing introduction. So, as most of you know, in R2M, we do the journey from research to market. So we started many years ago on the innovation side, working on these type of projects. Then we had the, let's say, market skills to supply the market, consulting market with energy simulation, dynamic energy simulation and commissioning activities. So then LEED and BREEAM, so on, arrived to our country, let's say in Italy first. And that created the demand of these companies into the market. So we started to sell these services, energy modeling and commissioning to start with. And then all the other kind of building certification kind of consulting services. So we were doing this, we were working new projects. In new project, we were touching so many innovative things like we will see today on these new projects. And then we realized that even if we were doing commissioning, modeling, LEED, BREEAM in the best projects in Italy, we realized that in this best project, design team, construction site, the technology level was very low. And these were the best, so they were supposed to be the best. So then we quite quickly realized that there were a lot of opportunities to bring whatever we are discussing here today or whatever we are developing here today that is already strong in some of the markets into our markets where we were doing consulting. Why? Because all the clients that want to have the LEED and BREEAM certification stamp, they do it because they want to increase the value of their investments in their real estate projects. And if they do so, they are interested in added value. And if they're interested in added value, they are likely interested in innovative solutions. Then the journey started. We are now more than 10 years down the line. And one of the examples of taking these kind of technologies to the market, it's our long-lasting, strong collaboration with IES, where we distribute the software, we do the training, and we help top engineering companies in our countries to use this platform, as well as bringing it to sustainability consulting and both at building scale or city scales with the reinventing cities. And just on this, let's say we as a value proposition, we bring this ecosystem, which is called the R2M Solution ESG Digital Twin Ecosystem. And the reason why I'm just showing you some things of IES, especially, which is one of the verticals of this digital twin ecosystem, is that just to give you an idea of what we are doing, we're going to discuss in the workshop our current development. This current development tomorrow will be reliable and robust to be sold into the market. I just want to show you how we are already selling parts of the solution that are being developed in these projects because they were developed in previous projects. So the journey that we have been through with IES on the research to market part. So the IES a couple of years ago started with it's been 30 years and I won't take too much about IES because they will present themselves, but the idea is that IES was started around 30 years ago, being the leader of very detailed, specific building simulation on the building scale. And now I will do the speech I normally do in Italy when I go around and say, the idea is this is a super powerful engine, and IES a few years ago had the good idea of saying we are having this powerful engine and we are only using it, for example, in a LEED model, in LEED certification, just kind of order of magnitude, a client today spends, let's say, 10,000 euro to get this building cert model, very detailed, and get a point, then the number of points that you get in LEED certification. So you spend 10,000 euro, you get one number, that's it. I guess at the idea of we have to use this powerful simulation not only at the very end of the design just to get the number, but we have to use it in other times during the phases of the building life cycle. We have to use it when we have little informations, like when we want to model things at the very large scale, like city scales, or existing buildings where we don't have much information, but we want still to make this simulation. We want to use the simulation during building operation and not only in the design. So we want to enrich our models and make them more reliable and validated and calibrated with the real-time data. And we want to see how these buildings interconnect with each other. And for each one of these kind of let's say market needs, IES developed tools that are assembling this ICL ecosystem, and then they can be accessed with a collaboration platform. A few examples. So let's say today, big real estate companies, they have a big pressure of decarbonize their assets. With IES, to decarbonize your asset, you have to do, like on the top right, you see a small table with the CapEx planning. So you have to say, okay, let's spend this amount, and you do relamping. And all these exercises is normally done by finance people or technical people, but they are not building energy model. And normally it is not done with an energy model. So normally, to calculate the impact of relamping is done with an Excel sheet where you calculate the electrical energy that you're going to save if you change this specific bulb that has a different power intensity. But you don't, if you do it with an Excel sheet, you don't know how it's going to be the impact of this relamping on the thermal side of your building. So if there was a way to make a very simple energy model that is a dynamic simulation that can be calibrated with utility bills data, and on top of which you can run a decarbonization scenario and plan your CapEx investment for your building, that would be great. And actually, this is what we are able now to do, because to do this model of this Hotel Armani in the Milan city center, instead of spending many days or weeks to do a very detailed energy model like you do for LEED, in here you can do it in hours and days. So very like one order of magnitude less, and you can support the decarbonization scenario better. And now that the investment funds are required to monitor all their ESG or their performance, environment, social, and governance performance, these solutions are very important. One other aspect, again, touching about the EU research. I'm not sure, is any of you familiar with the CREM indicator or CREM project? By raising hands? Nobody. Okay, good. This is like, go and check it out. This was a very successful European project that was done like many we do here in the research world. But they had a very, very good intuition, and actually they are making a big impact on the real estate sector. Why? So basically they calculated, and they have an Excel sheet that is available, so anybody can go online and get it. And this Excel sheet can basically set up a curve by 2050 of the maximum emission that your building should have if we want to stay within the 1.5 or 2 degrees temperature increase for the Paris Agreement. And this is today used in the real estate world to do things. And this is a EU project results that, there are many EU projects that none of us is always familiar with all of them, but this made it through to the market and is actually industry standard now. And have all the pension funds that have assets, when they make investments now, they ask us, which we are a consultant, what's the impact of CREM? And then we do it. So, and of course, if you have models that can help you make this calculation better, even better. So examples of detailed modeling, and what I mentioned, example of integrating with real-time data from buildings, both to, let's say, validate, calibrate models that can be used and be more robust, as well as being, let's say, live models to be used during operation to provide benchmark values and energy management support. I mentioned like a building scale. This is one just a flash on city scale. This is Piazzale Loreto Square in Milan, and I'm not sure anybody familiar with the Reinventing Cities program. Okay, somebody good. So at the C40, which is the top 40 cities in the world, they have put together this renovation package, which is called Reinventing Cities. Was launched in France for the first time, and now it's spreading around the world. So there are 4 Italian cities that have started to implement this. It's basically a package that helps cities to organize tenders for private-public partnerships to regenerate the urban areas, doing it with private investments and, let's say, lending the area that is owned by the municipality to the the developer and investor for maybe 100 years. And all this is just to regenerate urban areas with many indicators on the energy and environmental impact. And on this, we have worked successfully on these projects. Like in others, this was the most successful. With, again, modeling on the first part. Then these models, which were used at the beginning, are now being used for leads. So they are going one level deeper in terms of modeling. But we are working also at the city scale, not only for urban regeneration projects like the one we saw, but on the city side. So not on the, let's say, competition and the design team competitor side, but also on the city side. This is an example of the City Exchange project where we have been with IES in the Limerick city center for developing a decarbonization scenario from here to 2050. And on this, like now, if anybody of you have heard of the EU mission for the 100 climate neutral cities, smart cities for 2030, there is 100 cities being selected in Europe to be neutral by 2030. In Italy, we have 9. Milan is one of them. It's basically we are working with these cities that now they are committed. They have the stamp of the EU that they have to be the top 100 cities, but now they have actually to do. They need to do it. So they need tools, and any of the tools that we are working on, like the one we see, that are very useful to them. So now I will just go back to the EU side, and I hope that this was kind of stimulus to see that things that we discuss here today, tomorrow will lead the market side to do better and to make real impact. So that's it for the introduction. I just leave the floor to Dimitrios for the first project, and thanks.
Thank you, Andrea. It was a very nice introduction. Okay, so I'd like to follow up from Andrea regarding the part of these tools that we had, like analysis of the building in the design phase, and we wanted to do something beyond that, and that's where the idea of iBECOME came. Like it's a ED fund project about, as you see in the title, intelligent building energy assets control for comfort, energy, flexibility, optimization. So now I think I'll skip this one because the introduction of IES was really good, just to show you some key information. Like we are primarily a software company. We use our software in consultants project, and through R&D we further develop our software, and it's primarily for building analysis and building performance analysis. As you see at the moment, 75,000 projects per year are being developed using IES software, and our vision is that we believe that every building of every city in the world can be decarbonized, and our purpose is to develop the technology to make that happen. And our ultimate goal, aim, is to create a built environment that is resource and energy efficient, eliminating global reliance on fossil fuels while promoting comfort, health and well-being, and fairer access to the energy for every citizen in the world. So that's where we focus, and we provide the technology to everyone for that vision. And through R&D project, we are trying to use and further develop this technology and bring it to the market. So now, regarding iBECOME, it's a project that is a collaborative 10 partners from 4 countries, and it's demonstrated in 4 demo sites. So we're currently in month 36, and hopefully we reach month 48. Now we got like a 6-month extension, so we still have like 1 year. And we're at the stage where we are now doing the demonstration activities in the demo sites. You will see in a bit which these demo sites are. So iBECOME wants to demonstrate a combination of technologies for reducing bills in a building or facility through energy savings and demand response, while improving the comfort and well-being inside the building by using IoT, data analytics, and efficient control of a building. And in parallel, enabling even further more services for that building. So why we do all that? That's our motivation. And apologies if you cannot see from the back those bullet points. So things that we in this room, I think we know already. We spend most of our time inside the building. Usually we face poor comfort and well-being inside the built environment. More than 40% of energy and 36% of emissions are attributed to buildings. And these are figures in Europe. And roughly 75% of our building stock is energy inefficient. And we see in the past years this IoT big data evolution. And as in the building we are today, perhaps there is a lack of intelligence and interconnectivity. So our buildings are not so smart. And of course, we're trying to bring a solution to every building, even the smaller ones that do not have the intelligence of, for example, a building management system. That's why we call it a virtual building management system. So we use the data, whatever we can get from the building, or if we can install some, like from the market, sensors, whatever, or if there's any sensors on the building already, we're trying to use it. I'll show you in a bit how we do this. And we analyze the data, we create energy models, we use machine learning to do forecasting and deploy to the building some services in order to trigger energy savings, improve the comfort, and through the energy savings to monetize them and try to bring even more retrofits to the building through that savings. So we have a core services and additional ones. So the core services are energy and comfort optimization, measurement and verification, which is the process to monetize and estimate in good accuracy the energy savings, demand response, fault detection and diagnosis, predictive maintenance, and these are like as a group we split these services, and each group like trying to work and deploy these services into the demo sites and prove and validate basically the outcome. Additionally, through the data that we generate, we enable additional services like healthcare management. This is a service that will be trialed in a care home in Italy. And EV charging optimization and car sharing, where employees working in the same building, they can like optimize the route that we're following every day to commute, and also there will be an app to enable the car sharing. And of course, if you can think more, feel free to reach us with more ideas. So the idea is that through energy data and non-energy data that we collect in a building, we share the data and enable even more services than the core ones that we will study. We're studying in the project. And additionally, we have two business models. The Agile EPC, which is a direct agreement between the stakeholders that are delivering the services and deploy the solution to the building and gain a revenue from the operational energy savings. So let's say that we save the X amount of money through energy savings, and we reinvest that to buy more equipment or to do a retrofit. And through this route, the goal is to reach the decarbonisation of the building. And the enhanced EPC is to determine first the optimal retrofit, deploy it, and then do again continue with the agile EPC. Okay. So as a project, as iBECOME, we are using some specific software, and we like if there is no infrastructure in the building, like any middleware, any BMS, any way to transmit the data from the sensor that we place into the cloud, we are suggesting these tools. The one on the left is the enterprise server, is a commercial software by Schneider Electric. It's a software to manage BMS from the cloud. iScan, which is a tool from IS used to analyze data from any source and collect from the building, like from sensors, from meters, also virtual data from simulations, all can be managed there. We developed in a very good scale a calibration tool that is removing many manual steps in physics energy model calibration that try to automate and put on the cloud the process of improving the performance of a building digital twin to replicate the reality as much as possible. That's what's calibration, and this process is a very lengthy, requires expertise, knowledge. With this tool, we're trying to remove manual steps, reduce the knowledge required, and make it accessible through APIs. And this way, we use it on the cloud, not human, but with API, like from one software piece to another to be used. And we use results from calibration in energy optimization of the building, and the APIs for third parties. This is required to spread the data to a third party. So now our demonstration is focused on 4 buildings. On the 2 on the left are where we don't do any retrofit. The first business model, the agile one, we just do an audit, see what's missing in terms of like sensors. Like the one you see there, there is a sensor, I think environmental sensor over there. We place like off-the-shelf equipment, cheap ones, like could be a smart thermostat, which costs like €100 or something, that works on the cloud. We can control it. We can connect it to enterprise server of Schneider. Then through that, we can send signals back to the building to switch on, switch off the heating, program it. So that's what we do in Country Crest building, which is a potato processing facility, and Helix building in Glasgow, which is IS headquarters. And on the right-hand side, 2 bigger buildings, care home in Italy that will be basically replaced with another demo site, unfortunately, but a similar case, where we combine the deployment of the virtual BMS with retrofitted buildings and see the added value in retrofitted buildings. To close my presentation, I'll show you a little bit more detail about the case study in Helix building, which is a small medium office in Glasgow. Like it can host like up to 180 people. It's mostly leased by IS, and it's basically a building where, at the moment after the pandemic, it's we're doing flexible working, like in groups. We like some people are working from home, some people come to the office. So there might be areas in the office that are empty but heated. So there is a room for improvement in energy in this new situation now. You see, there are already some sensors. Top right picture is a environmental sensor, measures temperature, humidity, CO2, and motion, and illuminance. It's already placed into the building. So that's what we found after our survey. There is a electricity and heat meter already, but not on the cloud, just measuring for the bills. A digital thermostat, again, not on the cloud, and some conventional TRV valves for the radiators. There's no BMS, just those IoT sensors. The heating is on a weekly schedule, like 9 to 5, Monday to Friday. There's no local heating control in every room. There are just 2 thermostats, one on each floor. And each floor has an open office area, some meeting rooms that are used occasionally. We found that there is temperature difference between zones. We made a survey with the people working there. They told us their problems. In very cold winter days, the heating is not enough and preheating is not enough. Meeting rooms are either cold or overheated, very rare in comfortable temperature. And also there is an energy model. In a hard drive somewhere, there is a physics energy model created with our platform, but not used since we complied with regulations. And there's air quality issues. And as I said, flexible working. So I was wondering to ask you here, like, do you think that this might be a representative building that we see a lot in the current building stock? Probably it is. And I found some stats to prove this concept. Like, if you see in the red area at the moment, it's the 50% of the buildings in Europe. And out of the commercial buildings, 23% are offices, which accounts to a total of 1.4 billion square meters. So we're talking about a huge building stock. And at current renovation rates, it will take over 100 years to renovate the entire building stock. So that's some figure. So, but the idea starting with this software solution, like a virtual BMS, we can reach faster to this goal to recarbonize and clean the building stock. So conventional now, if thinking as a building owner or as a facility manager, we tried to install some equipment that is cheap. Like we bought a Wi-Fi thermostat that is portable as well, but we can access it through the cloud. We place some smart TRVs, as you see, top right picture, on the replace the valves on the radiators. Again, on the cloud are working. The protocol we used for this was the LoRa, if you are familiar, LoRa 1 protocol. Window sensors. We managed to bring the data from the heat meters and energy meters to the cloud. And so we created a workload for our office manager to navigate daily or weekly to 4 or 5 applications, one for the smart meter, one for the smart TRVs, one for the window sensors, another app for the heat meters. And that's a quite significant workload. And to compare the bills, to find out, did we save? We didn't save this year. No, we saved this year. To receive complaints. So our office manager, actually before we deployed anything, we installed this and she started to receive complaints. This area of the building is not very well, it's not comfortable. So she was trying to adjust the heating. We were trying to adjust the heating until we deploy some solution. Spreadsheets. Copy and paste from one app to a spreadsheet, then from another app to a spreadsheet, do comparisons. And call a technician when something fails. So we were waiting to see a valve failing. We faced that. We replaced a valve like this, a TRV, and it was, it started like, we detected humidity on the sensor, so it was leaking. So then we called the technician, and we had the idea of a use case to be able to track through machine learning if the valve is going to break. So we go there and fix it before it fails. That's one solution we deployed. So with iBECOME Virtual BMS, what we propose is we get all the data into one place, iScan software. So in the cloud as well, from every place, someone could log in into that platform and see all the data from all the sensors, all the meters, virtual data, real data, forecasts. Everything is in one place. From this place, we bring the data to specific dashboard for each user needs. Is it an occupant? We do a dashboard like this. Is it like the building manager? We do a specific management based on a specific dashboard based on their needs. So you cannot see that very well, but this is a dashboard for one room. It shows the daily average temperature during the occupied hours of the room. How many minutes I can zoom, do you think? Or
Probably yes.
I don't know how much time I have. Okay, so that's the dashboard solution. Alerts for data gaps or for anomalies or for failures, for doing like a fault detection. Since there is only natural ventilation, we install some LED lights that track that CO2 is going above the comfort levels and flashes red, so people know to open the window. Again, we use this old model. We updated it and calibrated it to make predictions and create scenarios. We trained algorithms through that results of that model to do comfort predictions, fault detection, battery degradation, predictive maintenance to replace the batteries of the sensors before they go offline, and the control of heating through data-driven, occupancy-based in meeting rooms, and comfort optimization in open office areas, and smarter preheating of the building. And demand response advisor by using data from an external source, which is energy price or carbon intensity forecasts. We advise the building occupants to charge perhaps 1 hour later at that time where the energy is cheaper or there is no a peak in the demand or the carbon intensity of the electricity in the grid is lower. And using our physics-based model, we calculate the energy savings and we prepare what-if scenarios for the full, hopefully, the decarbonization of the building. And so far, we achieved to see this winter's 4% energy savings in meeting rooms that will pay back the new devices we bought in 2-3 years. And of course, the comfort was hugely improved. The presentation I gave this morning showed that in an open office area, we can achieve an additional 5% energy savings with a 3 to 4 year payback. And we, of course, provided the transparency to everyone working in this building in energy savings and comfort conditions. And that's a table that shows all the listed scenarios, retrofit scenarios we discussed with the building owners, with some engineers, in-house engineers, and we analyzed with the iBECOME Virtual BMS. We still don't have the results, as you see, the table is empty, but in following presentation of iBECOME, I might be able to show you those results. And that's the SRI we calculated before and after the deployment of iBECOME solution. Smart readiness indicator before, 15% after, 55. And just to close quickly, our next steps is to deploy all the services we have and compare and evaluate the benefits and discuss with the occupants. But we need more winter time to do so. Our solutions are optimizing the heating mostly. To finalize the decarbonization roadmap and emulate the deployment of these EPC contracts and hand over the dashboards to the office manager and collect feedback. and measure before and after energy and comfort benefits and evaluate the virtual BMS. And that's it from my side. You are more than welcome to subscribe to our newsletter and follow us on social, and visit our website where we regularly publish our reports. Okay, that's me for the moment.
So next one is Beatrice, also from IES. She will give us an overview of the How2Learn project.
Thank you. Hi everyone. Well, it's a very full room actually. Like from my seat, you couldn't see how many people is behind. So nice to see you all. It's very nice to see a full room. So I'll be my name is Beatrice. I work along with Dimitris and all my colleagues are presenting today in R&D team in IES. I'll be presenting How2Learn. I don't have such a great case study as Dimitris presented. It's going to be more like a general overview, key objectives, and some results that we have at the moment. Hopefully next time I can do a case study too. How2Learn is literally stands by these long sentences. We'll read it, and probably I hopefully can explain to you throughout the presentation what's about. But it's deploying augmented intelligence solutions in European buildings using data analytics, interoperable hardware software architecture, and a self-energy assessment methodology. I know it's long, but I'll explain you to like in a more simple way, hopefully. So first I'll give you some context and introduction, objectives that this project has, and then the platform and the demo site, which is the main context and the concept behind the project, and then the hardware solutions and some results that we got so far. So yeah, what was the driver? Like the driver behind that, like we all know aware of this energy crisis and also the ambition that we have at European level to reduce not only final energy consumption but primary energy, but however the problem is there's lack of automated systems in domestic buildings, and that's a problem because we all know if we don't have data we can't improve anything we done in projects. So, and that's where How2Learn fits in. So the main objective of How2Learn is giving home residents with the information they need for reducing energy and like energy consumption and also energy cost. We'll do that through data analytics and energy data collection, and then provide them with recommendations and possible actions they can take. I think it's important to remark that augmented intelligence is a concept that involves the human part also. It's not like in artificial intelligence, we kind of try to automate the whole system and make it autonomous. But here we do need the humans. So we need that combination of machines and humans, which is nice. So we won't be replaced with How2Learn and augmented intelligence. But I think that's something I've learned through this project, that we need both. So I'll go back 1 second. So the introduction of the team that we are in How2Learn. And so we are ourselves coordinating the project. Then we have TU Dublin, Semicon, that they are responsible for, they manufacture electricity meter, and they're using How2Learn actually to make it commercially viable. So then we also have Okulen, that they have affordable housing and they offer a demo site. We have the University of Burgos and Cardiff. University of Burgos give us also like a couple of demo sites. Cardiff is helping a lot in the interoperability of all that and how all these components work. Then we have Rina, that maybe some of us are here also. They're like helping a lot with the dissemination. Fairbit is gonna give us the data. I'm gonna show later the data integration of all the IoT systems. We have Artem Solutions that they already presented themselves, They also have a pilot in Lisone, like a special one actually, which is a theater. Then we have Deltacopolis with another pilot, and Arçelik in Turkey that they're providing the smart appliances. So what are the key objectives? There are 5 key objectives that Autodan has. We need to create this smart hardware infrastructure that works in domestic buildings. That's a challenge because everything needs to talk, everything needs to be simple, talk to each other, and show a basic solution for easy to understand for non-technical users. We have to develop the interoperable software, the augmented intelligence solution that is going to be shown at the end in dashboards. Then we have to create the live energy assessment method that includes everything, includes well, not everything, but includes operational monitoring, also includes the appliances system and the smart capabilities of the platform. And last but not the least, accelerate investment in sustainable energy by European companies. So that's the platform. That's a basic schematic of the platform. So on the left-hand side, we have the smart hardware infrastructure where we have a BMS system, IoT sensors, that they will send data to iScan, the data analytics platform that we do have. And in between, it's not showing here, but we have FlareBit that is actually, thanks to them, that we are trying to collect all data there, they store it, and they actually send to us. That data then feeds the software, and the software consists of 2 parts. We have, on one side, the digital twin that takes care of the building level recommendations and the building level optimization part. And then we have the digital occupancy model that takes care of the appliances level recommendations. And that at the same time, that fits the self-energy assessment framework. For now, like I thought of showing you like the demo sites that we have. So we have 6 demo sites for now, and we developed the physics base of all of them, but it's still waiting for data. You know, everyone knows that I think like the challenge of installation in these projects, like this is a delay at the moment. So getting there. We have the affordable housing in Ireland, domestic houses. We also have the theater in Italy. We have the Vida Foundation in Burgos, that's social housing. We have a cooperative, like an apartments in Milan, student accommodation in Spain, and then a small, a business park in Dublin. That was a challenge because each business park has different usage needs, and it is a difficult one to understand and collect data from them. That could be I think that would be my case study. If I have to choose one, I would choose this one. But when I have data, I will do it. So that's the hardware solutions. The hardware solution, we have one side the energy monitoring. And energy monitoring is the electricity meter that M Semicon has manufactured. So it is a 3-phase electricity meter that you put in the income panel and then sends data through Wi-Fi. Then we have the smart plugs that they are used in appliances or equipment in the houses. We have the smart appliances. We have environmental monitoring that they do relative humidity, CO2, and indoor temperature. And then we have these communication devices where it's just like a home, like a smart hub where all devices send data to, and then this hub send data to us. The last thing I'm going to explain to you is just a couple of results we have for now. As you may remember, the software has 2 main parts. One is the digital twin that we are waiting for data to develop the full twin of the buildings. And on the other side, we have this digital occupancy model. That what does it do? This digital occupancy model helps users to schedule their equipment based on the energy prices. So it can tell you next day recommendations on when it's best for you to use your dishwasher. Okay, and it has 2 scenarios. So we work on 2 scenarios. One scenario is we will have only load for the full load of the building, or we actually have smart plugs and we can get data straight from the appliances. So if the case is that we have the data from the meter, the full building, we need to do load disaggregation, and that's one of the components. There are 3 components in the model: the disaggregation, the clustering, and the next day optimization. The disaggregation is when we have to do the breakdown, when we have the power of the building and the whole building, and then we have to do the breakdown for appliances. Then in the clustering, using machine learning techniques, we identify when the patterns of when you use each appliances. And then in the final step in the optimization, we do have those recommendations where it tells like what is best that you can use your appliances. So that's one of the results. Another result is like the final user dashboard. That's what I presented this morning as part of this project. This is the final prototype. This is like an overview of the final prototype. The work behind the dashboards and the UX design, it is very challenging because you have to put all disciplines together. It needs to work with the backend, but you also have the UX design that needs to make sure that what we are delivering meets the user needs. And that seems easy to say, but many products, like after projects, like they actually don't meet the user expectation. So part of this work a lot was to make the user part of the whole process, not like a client, but a core stakeholder in the process. And that's a bit all. That's me. So this is just how to keep in touch again. Like we have our website, LinkedIn, Twitter. We also release like a newsletter every 6 months, like many of us have to do. So please, you can subscribe and ask any questions now. I'm here to help.
I suggest we keep them
Good.
to the end.
Good.
So thank
Good.
you.
Thank you.
And so the next step is a quick. So I'll ask you to get the mobile phone. We have 3 questions for a poll prepared. So let's see if it's still connected. Okay. So you should be able to see with the QR code, the top left. So there are 3 questions on, generally speaking, on enabling technologies. So mainly around BMSs. So the idea was to collect your opinion. There are 3 questions. Has anybody managed to get in?
Yeah.
Good. It's really a success. Good. So the idea is first question is from your point of view, what are the most significant drivers that could convince potential clients to invest in advanced BMS platforms? And the idea is to rank them. You can double tap on the answers on the phone, or then drag them above or down the list. And so it's either energy and economic savings, increase of productivity of employees, in case of office building, for example, revenue from flexibility services, diagnosis of building energy usage, building value increase with possible certifications like LEED and alike, or interoperability of the HVAC equipment. Okay, so I'll move on to the other question. We'll see at the end of the list. I think on your phone you can submit the answers, but I'll keep going with the questions and then come back. Second question is, from your point of view, what are the main? No, that's it. Second question. Yes. To overcome the replication, so again, from your point of view, what are the main barriers to overcome the replication of advanced BMS platform into ESCO market for commercial and industrial buildings? So difficulties in implementation of performance measuring and verification procedures, uncertainty in the energy economic savings expected, competition with standard energy efficiency measures, the efficiency of suitable local technology providers and skilled personnel, and incompatibility with existing devices due to properly communication protocols. Okay. Okay. Perfect. So just to go through, like pick the first choices so far. So in terms of, it's still updating with some of you, is submitting the final one, but let's say main driver for BMS platform is, I mean, it's again energy and economic savings, but as well diagnosis of building energy usage. So this is a bit the ranking. The results will be published at the end, so I won't do too much into detail now. So in terms of the barriers to overcome the replication in the residential building market, the main one is still the initial investment. So seeing today kind of cheap devices to be deployed, it's clearly a good, I would say, line of investigation and exercise to do. And then the last one, it's for the market of commercial industrial buildings and ESHER-rated services. The main one is difficulties in implementation of performance measurement verification procedures. Okay. I can share the experience. We work with AI-based solution that guides HVAC systems like in an autonomous way. And they started the business model selling the license for as a, like, let's say, energy saving share. And then they decided to say, okay, it's too hard to calculate it every time and recalculate, reassess models. Let's agree on a flat-based measure for paying for the service of automate this HVAC system operation. And yeah, that's it. Then there are more savings, better for the client. If there are less savings, it's better for us. But at the end of the day, we make sure that we are all happy and continue. So thanks for this kind of short break. Now, we have our third presentations of today, which is Manisha, the STEPUP project. Manisha, sorry. Please, the floor is yours.
Thank you, Andrea. So, I'm Amisha. I am coordinating the STEPUP project, and I won't be going into a lot of detail about what IES does because Andrea and Dimitris have covered this to a great extent. But let me brief a little bit about how STEPUP is approaching digital twins and the IoT devices, smart technologies in the pilot buildings in the project itself. So STEPUP project is focusing on an iterative methodology for deep renovation. As we know, there is a deep need for renovating and decarbonizing the environment, but so far shallow retrofits are the way to go. And there needs to be a change in that because although shallow retrofits like small changes in the building envelope or the HVAC system can bring about energy savings, real and big energy savings can only come by deep renovations of the buildings which need it the most. So that's the target of the STEPUP project, to achieve that to a certain extent, make it more attractive and reliable to do deep renovations. The methodology in itself is very focused on data intelligence, tools and software that can enable this kind of development to happen. The key objectives of the project are to make renovation more attractive and reliable, reduce the performance gap, and optimize renovation investments using innovative financing models, minimize time on sites because we are using plug-and-play technologies to enable the reduction of time on site, and accelerate the renovation market using these different solutions. So these are some of the technologies which are being developed in STEPUP project. Plug-and-play envelope system, as I mentioned, flexible heating solution, which is a PCM storage tank combined with some intelligence, which observes the charging and discharging times that can be used in the building, and how it fits in with the existing technology, innovative financing tools for deep renovations such as smart EPCs, and software tools and platform for data collection. That's where IS comes in to a great extent, and I'll be focusing on that in this presentation. So how are we using digital twins to optimize deep renovations, driving zero carbon? It really is in the heart of this project. And I'll be talking a little bit about this life cycle platform which we worked on. So on the left, you can see the different phases of the deep renovation that was identified after a lot of engagement with stakeholders and participants in the project. So it looks very familiar to a normal renovation process in which there's a feasibility phase where you're investigating whether a building or an area is feasible for deep renovation. There's a preparation phase where you try to make a business case, try to investigate this a bit further and get the data of the existing buildings to analyze it more. In design phase, you are finally designing the solutions that you need to do the deep renovation. In the implementation phase, you have implemented the solutions, and you use technologies such as lean methodology tools to make sure you're minimizing waste and optimizing the construction process. And in the operation phase, you are looking into the operational performance of the renovation process. So the lifecycle platform is a suite of tools. It's a collection of all these tools, and it's accessible at different phases of the renovation process through a project management portal. So that's sort of what we've worked on in this project from the software and tools side. These are our 3 pilots in the project currently. Zöldliget Kindergarten, Budapest, Hungary, Monasterio de Las Pamplona, it is a apartment building in Pamplona, and Helix office, as Dimitris has already shown before, it's the headquarters of IES in Glasgow. So some of the ways in which digital twins, smart technologies are being used in the project. On the left image, you can see the project management portal. So it's a very simplistic checklist of going through the deep the renovation steps included in the STEPUP methodology. At each step, there is access to the tool that is recommended in the STEPUP project to be used at that step. And so different stakeholders can access this and use it. There are different access levels to different tools, and the end user of this portal is supposed to be a deep renovation manager who sort of manages the whole renovation process. On the right, you can see an example of a dashboard. So this is from the apartment building in Pamplona. We have installed IoT sensors in some flats of the building, and we are monitoring the CO2 and the temperatures and the humidity levels in the buildings. And we also created digital twins, as we saw in the previous slide. So those are the energy models created using ISV software. So once we had some more data from the building, once the IoT sensors and metering system were installed, we recalibrated using this data. And again, as previously mentioned, we calibrate the energy data, and we also look at the environmental data to see how it matches with the digital twin. We also use the ISM platform here to analyze during the feasibility stage to see which buildings are appropriate for deep renovation. This is appropriate for stakeholders during the early stages of feasibility, where they need to see which buildings are performing the worst and they need to be targeted for deep renovation. Again, the ability to access information on these buildings, such as energy data and also the envelope data, etc. It's vital to create this kind of study and analyze the feasibility of solutions. And other things that we did in this project using data was data gap filling. So you can see on the left, there are some data gaps in this particular channel that's coming in through our data collection database called iScan. And this is air temperature in one of the flats. And once a data gap has been observed, we get a notification saying there is a data gap, and if you can run an application to fill in this data gap. And on the right, you can see that the data gap has been filled. You do need some previous data to allow this algorithm to work, so it understands how it normally performs and how it's expected to perform. Monitoring and verification using monitored data. So we have monitored data on the iScan platform, and this monitoring and verification application basically shows, observes a period of time after the deep renovation has taken place, and it measures the energy savings that are expected versus what is actually taking place, and it reports on these and gives some insights on how it's expected to perform. Fault detection. So in this particular example, we are observing CO2 data in the Hungarian pilot, which is a kindergarten, and yeah. So in this, the fault that has been detected is that there is the CO2 levels are higher than the well thresholds, well standard thresholds. So it reports that as a fault. It depends on what kind of rules you give it, and in this was a rule that was declared. So if that is decided to be a fault, it reports on the information about the fault, when it was detected, what was the period that it was monitored for, and possible solutions or possible issues that could have been causing this. Thermal comfort prediction was another study that was done in this project. So we installed tablets in the kindergarten, and we allowed the occupants to feedback on how they feel thermal comfort wise. It's in Hungarian there, but basically it's pretty obvious. In the middle, you're happy. Towards the right, it's too warm. Towards the left, it's too cold. And we collected this data over 3 months, and we are continuing to collect this data. This feeds into machine learning algorithm that learns how the building is performing, how people are feeling thermal comfort wise, and it creates a a stronger thermal comfort model, which is able to predict then how a building would perform. So this was something that was developed as well. So in summary, smart building technologies such as IoT technologies, smart meters, all of this has enabled digital twins to gather this information and do some really useful stuff out of it. And it is vital in spreading smart building technologies. So that's the kind of summary of the STEPUP project. And I think questions towards the end, right?
Yes, we are the last presentation, okay. Then
yeah.
One question per speaker.
Perfect.
So the last presentation is from Naya, and it will be on the ESHER project.
Cheers. Thank you. Don't know if this is convenient, but I'm actually not managing this project, but it's another Noel, so it's almost the same thing. I noticed the slides are a bit old in this one, so the energy trading part, I'm going to kind of scan through and describe that more than rather than look at the slides, because they're a bit painful to look at. So essentially, the ESHER project is actually somewhat linked to Beatrice's project that she described earlier, in that we have the same pilot site, except we're putting more focus on this pilot site, which is based in Ireland. And essentially this is, I guess, it's using smart buildings, but focusing on the kind of demand response side of things, optimizing the energy use within that building to help with peak loads. So that's kind of the overall arching theme. And there's a nice part to this because it's social housing essentially, so lower socioeconomic occupants. So being involved in these projects is actually has a quite nice, I suppose, morale to it. So it makes it's a bit more feel good when we actually get these things working. So it's an SEAI project, which is the Irish Agency for Energy. So they funded the project. So they get a wordy mention. And because my colleagues have already described a lot of the themes and a lot of the concepts around how, I guess, smart buildings work, the Internet of Things, and how the digital twins interact, I'm going to just try and scan through these slides as quick as possible just to get to the key points. So, so we won't get caught up in too much detail. So these are the three partners. O'Callum is a social housing developer, building low-cost housing. So it's kind of like an NGO. Technical University Dublin, and then of course ourselves, IES, who you know for a bit about at this stage. So this is kind of the concept. We are trying to take smart buildings that are being used now without any smartness, if you want. We're trying to use our software and our digital twins to optimize the building to essentially make sure that the renewables on site are being used and optimized the best they can be, but also to help demand response at a greater scale. So help the DSO essentially. So the top here we have an unregulated or unoptimized load profile for a single family home with a single parent occupant. And with our work from using iScan that you've heard of before, with all the sensors in the building and a proto persona developed for iScan. So a personality that optimizes based on the occupant, but also the actual equipment that's in the building. We can create this load profile for them where they're, I suppose, they're prompted to use certain equipment when it's most, when it's best to use it to meet this load profile. So a part of the project towards the end, which I'll talk about in a little bit of detail, is peer-to-peer energy trading. So the pilot site has several buildings with PV panels and batteries, as far as I'm aware. And so they're all on the same branch of the grid. So there's capacity there to actually trade energy with each other. This isn't part of introducing the peer-to-peer trading. It's not part of the scope of the project, but because we have all the data and the infrastructure, we can test it in a sandbox infrastructure to see, whether it's something that's worth exploring. So for those of you who don't know, peer-to-peer trading is essentially where you can actually trade energy you're not using with your neighbor's house or someone along the same branch on the grid with you. And these are really impactful if they function correctly, because we can encourage people through financial incentives to optimize their energy use and focus on using local renewables. So here's the pilot site. It's a place called Ballymun in North Dublin. It was originally what you would normally see around Europe, concrete tower blocks, which were deconstructed in the late early 90s, and all the inhabitants were put into brand new smart houses and A-rated homes. What's unusual with these is that the houses themselves are brand new, but they have to choose between PV or heat pumps. So a lot of them went for PV, which means that gas-fired central heating, which is strange, but it's just because of the costs that are involved with low-cost housing. So that's what we're working with. And we're looking at one specific building here, but it's a neighborhood that the whole pilot site's in, or at least one street. And this building, the original idea for the project was to put smart plugs on all the equipment, as well as a smart home hub and a smart meter as well. So we want to get as much data on energy use within the building, but we couldn't interfere with the occupants or do anything that would be, make them uncomfortable or impact the interior. So a few of these items have to be dropped. The smart plugs particularly, because they were essentially pushing out all the white good. The fridge had to come out of the actual cabinets, and the drawers didn't fit quite well with the plugs behind it, so we opted out of them in the end. Just a quick overview. We used these. I've never actually tried to say it out loud, but Bino smart meters. They were quite niche. They go into the actual into the cabinet quite comfortable. Don't cause any issue. No one really notices them, as you can see here. And then we use the Samsung Smart Things Smart Home, because at the time of this project, it was right in the middle of COVID, so it impacted the project in various different ways. So the Raspberry Pis weren't actually available on the market because of the semiconductor shortage, so we went for more available software, such as the Samsung Smart Home or Smart Things. So this is the iScan collecting data. In the blue line, we see PV yields per day, and in the green line, we can see demand consumption in the building. This is again a single parent home who are at home all the time with their kids. So this is their load profile. You can see the peaks in the morning and in the afternoon. And this is the real data that we work with. Then we generated a digital twin, for most of you who are familiar, that we generate these predictive models. So a physics-based digital twin to predict energy use within the building. Because of COVID, we couldn't get survey the site, so we had to just use drawings from the developers, as well as any information that we could get from the construction documents. So once we had this, we calibrated the digital twin with the real world data to get a very accurate depiction of the building itself. And this is the prediction models here we have for the PV. So we had PV data that we could calibrate our PV panels in the virtual environment, and then predict the actual electrical consumption based on the profile from the occupants, as well as all the equipment and the actual building itself. So we optimized a load, a new optimized load. So the solid red line, it's very hard to see actually, I'm going to probably skip by this, but basically we gave them a new optimized load profile that they should try follow based off the models that we ran from the digital twin to help them reduce costs and utilize their local renewable energy source, which was the PV panels. And then we got the UX team to help design a dashboard for them. I wish I could actually pull this and make it bigger, but below it is actually the testing of the energy trades with the neighboring buildings, and above is just the performance of the building as a whole. So this was a desktop study just done through surveys and interviews, and the UX team designed a nice dashboard for the users, which are the occupants, to play with. That's pretty much everything I described there. And this is our proto-persona development. So as we know, this is a really important part for demand response, knowing the kind of profiles of people and how they're going to interact with their environment. So this allowed us to understand the type of occupant, and therefore how we get them to interact with their building in the most optimal way. This person specific was more about costs or saving costs. And you can't see any of that writing because I can't, so I'll skip by it as well. So here's the trading platform. This is the P2P network. So I'm just going to skip down to the formula. Essentially, the logic that we applied, the normal P2P platforms, you can choose how you're going to trade or what way you'd like to trade. We just put one in, which is buy low, sell high, essentially, just like a standard market, all around trying to drive costs or get your costs back for the PV that you've installed. So essentially, this works on the premise that you just want to sell as much as you can at a good price during peak hours. So if your persona, the person prior, is at home all day using energy, they're not in a good position to sell high and to buy low because they're using throughout the day. Whereas someone who might not be at home all day won't be using any energy, so their energy is ready to go, and they can kind of dictate the price a bit better, undercutting the actual DSO, whoever's supplying to the local area. Sorry, these slides are quite painful. I had a lovely picture done of this whole trading, We don't really need to go through any of that, but it looks cool. And so P2P trading, so P2P trading essentially in this concept is just about optimizing energy use by incentivizing the occupants to load shift essentially, and then get money back for trading energy. And the whole premise is obviously to keep the local grid balanced within a nice healthy balance, and to help the DSO in terms of their in terms of bringing down the peak demand. So it's a kind of an all-rounder winner. The results are still yet to come. So we are just running P2P tests on this project, and another one called Secure, which is at a scale of about 500 buildings on an island off the west coast of Ireland. So we're looking forward to getting some of the results of these in the next 6 to 12 months. And it'll be posted by IES, so keep an eye out for it because there's some interesting stuff coming. So the next step with this is to actually unleash the dashboards and let them see how functional they are and see how informative they are, and then see if this can help bring down the energy budgets of these buildings in the social housing, and to see if people will actually use their buildings appropriately, really leverage the PV panels and really change their profiles to save money, and also to obviously reduce carbon in the grid. So, questions?
If you agree, I will call all the other speakers, so Dimitrios and Listener, if you can stay here for a bit longer. Yeah. And Misha, so if there is any specific point from the audience to as a wrap-up comment, question or something, we are happy to take it. Otherwise, I'll break the ice. So, okay, thanks.
Because I have a question to Alcida. That was interesting.
If you can just maybe just to for everybody to hear.
Yeah, I saw that you created e-models for each demo site. So my question is that you based on scanning or documentation 2D, or it's only the external part of the building that is enough for the making the perform analysis?
Well, they're not BIM models like they've done in IES. So in IES we can import BIM models, but they've been created on our physics-based simulation software in the VE. So they're not BIM models per se.
So it's like a 3D representation.
Yeah, we just build them from scratch in our software. So the same way you would do it not the same way, but yeah, we build them from scratch in the beginning. So we have the drawings, we put all the thermal properties and the heat transfer that is behind the simulation, but everything is built in IES.
And there are internal zones in the rooms?
Yes, yeah. Internal zone, occupancy profiles, materials, schedules of equipment too. Yeah, we are working also with that, importing that BIM also in our engine. At the moment, we have the functionality to import in the VE.
Thanks. Any other point or question? I'll go for one. So a few of them mentioned the calibration process, and Dimitrios, you mentioned about the self-calibration tool to transfer human knowledge into the platform. When can we sell it? So, or at least try it. So what's the forecast in terms of, because I think that's a very, very normative part of solving the issue.
We're getting there. We're now trialing this, basically removing those manual steps. And I think that commercially we're really close to releasing a platform, not for fully automated calibration, but to eliminate many manual steps to do sensitivity analysis to identify which parameters affect most the model, which bring the biggest uncertainty into the energy model. And also, we are trialing this first into these pilots we have in the EU projects, and hopefully we can reach the desirable TRL9, as we know, most of us know here, and release soon a tool like this. It's on our next goals, commercial. Yeah.
So my name is Maria Jimenez. I work for a Spanish engineering company, and we have a similar development as Mimosa. We are working in an energy-oriented digital twin, where we do a similar energy analysis and proof of idea to analyze for condition. We develop a different rate energy plus model. And so it is a tool which is similar to what you have presented. Sorry, I was a little bit late the presentation and I didn't get all the presentation for IBECOME, but it is also very similar to the STEPUP. And I will be presenting tomorrow that in the digital paper session. I can see synergy with what you do, and I can invite you to attend that. The paper I am presenting is called Digital Twin for Continuous and Accurate Energy Audits. So we do this for what we call continuous energy audit, and that is also very relevant to assess the renovation process, to have a very detailed view of what is not working, the malfunctioning of the system, and also to make better assessment of the investment that we do. So very interesting.
Be there tomorrow.
Each project had a concept and a methodology, and the Building Digital Twin Association is active now in position papers and presenting concepts and methodologies on how to do a standard approach across Europe. Ed was talking to me about that before. Ed, not you left. But I think he's interested to lobby for you to talk to him about that again, and they have a conference next April.
Okay. We see him, sorry?
Ed Moscos, he's the president of the Building Digital Twin Association.
I met him and he already signed me up for the next his next event.
He's just a normal guy like us that
Okay.
saw that collective effort and standardization in this area could benefit. Now he dedicates a lot of time to it.
Okay. Nice to know.
Well, I'm Anas Ali, Secretary General of the CTP, also partner in our twin accounts. I have a question which, in that case, maybe is not directly related to this digital twin development. So maybe you can provide some level of answer. You have been referring, at least some of you, about KPIs and how we are improving thanks to digital tools, the operation of the construction or renovation works. I'm wondering, how are you considering, in which way are you considering your baseline to, from where you are able, for instance, to provide the KPI? For instance, there was one example that, I guess, if I would remember, you referred to the fact that the time for the renovation work will decrease about 40% from the time now in terms of renovation. But what is baseline? What is your baseline? How do you, in some way, estimate or compute or whatsoever the baseline? And then, of course, applying your technologies, at the end of the day, you are able to demonstrate that the time is 40% less.
Yeah, I can take it. So the KPI that you saw, the time reduction by 40% in deep renovations, that is, it's not focused on digital twins, but it's focused on the construction process. So we are in STEPUP project, we are deploying plug and play envelope facades. So they are prefabricated facades built off-site and then installed on-site. And one of our partners, they're analyzing the time on site because they have information of similar prefabricated facade or industrialized facade system installations in similar deep renovation projects. How much time on an average that takes, that is used as a baseline. And then the time on site is compared by monitoring the time on site when we do the installation process in the project. So that's the comparison that's being taken there.
Thank you.
Marcus, please. Just one question.
to Niall. The Valley One project, what's the plan for when you're finished the project as regards to the actual houses that you've installed it in, or is it a single house?
I think there's several houses involved. I'm not sure. I don't know what the follow-up is. It's going to be, from my experience, an archetypal approach to any of those kind of developments, whether it be social housing or even bigger developments that are standard sale. It's an archetypal approach to show at what scale does this make sense, I suppose. So it's a use case first and foremost. But then we can just have a look at scalability. So if you build, say, so you're Irish, you're familiar with like Glenveigh and Crane, you know, they're building huge housing estates. And so in principle, we could help master plan those on a community energy project using data we understand from this. So that would be an aspiration, I'd say.
But the expectation of the house owners as it stands, is there any expectation by them to have this continue, or?
I haven't talked to any of them, but the let's say the personas that were developed, a lot of it was around financial incentives. So money back and trying to make your money back on, you know, investments that were put in the properties.
More personal to the Nile, that could be close to Ireland.
Yeah, Inishmore.
Yeah. You got data from React on that, haven't you?
We did, yeah.
So we might talk about that.
Yeah, no worries. Feel like I'm in trouble. Okay.
Or for the formula.
Yeah.
Question
Yes.
on the formula. Okay, good. I think we're just 2 minutes late, but thanks everyone for joining. I guess everybody will be available at the coffee break for any further follow-up question. And thanks again. We are done for this part of the session. Thank you.
Thanks for coming.